Bwahaha! This is your review, most of Chapter 8. Systems of equations when both are in standard form. Remember, standard form is when you have ax plus by equals c. The variables are on one side and the numbers on the other. More importantly, the x's could be written above the x's, the y's above the y's, and the numbers above the numbers. The constant term, above the constant term. When they're both in standard form, even though you can use either of the three ways for graphing, usually people use the elimination method. That's where you add them straight down. That's easy to do, it's intuitive. However, in order to do that, you will need to get rid of or eliminate either the x's or the y's. So in this case, I purposely wrote a question where nothing eliminates. A negative 3 to negative 5 is a negative 8. 3 plus 1 is 4. So we didn't get rid of the x's or the y's. So you have to think of a number that you can multiply one of these by or both of them by to get rid of the number. In this case, I'm going to choose the bottom equation, and I'm going to multiply it by 3 because this is a 3. So to get rid of it, I need the opposite of it. So if I multiply it just by a 3, it won't be right. You have to multiply it by a negative 3, so that because this is a positive 3, that will be a negative 3, and they'll be opposites. And you're allowed to do that in algebra. Just remember, whatever you do to one side of the equation, you do to the other side. So basically, you're just distributing it. It's going to every single number. This top one, we didn't change at all, did we? It stayed exactly the same. I'm going to rewrite it to the side here, exactly the same. But underneath it, we multiplied the bottom one by 3, a negative 3, and a negative times a negative would be a positive. Now, these are opposite. That was the whole point. So 15 take away 3 would be 12. These cancel out, they're opposites. 3 minus 39 would be a negative 36. What's being done to the x's is being multiplied, so divide to the opposite. There's your answer for x. To go back and find the y, you just have to substitute this answer into one of these equations. I'll choose the bottom one again, just because it doesn't have a number next to it by no coefficient. So it's a negative 5, but in place of the x, I'm going to substitute in this negative 3. So negative 5. Whoops, let me start over. Negative 5 instead of an x, we'll put a negative 3. Plus y equals 13. So instead of x was a negative 3, we got it from right here. Then to solve for y, we just do the order of operations. A negative times a negative is a positive. What's being done to the y is being added, so you would subtract. Running out of room here, but then the answer would be that y equals 13 take away 15 would be a negative 2. So x was a negative 3 and y was a negative 2. This is one way I can represent the answers. I can put them in parentheses. That's how you do them both are in standard form. Now, what if it's in standard form, but it has coefficients in front of each one? See how this y didn't have a number in front? Look at this. That they both have coefficients. It's still done the same way. You want opposites. Now, it would be really challenging to get rid of the x's here. Because if I count by multiples of 4, 4, 8, 12, 16, it never turns to a 7. So that's not very easy. But if I count by 2's, it would turn into an 8. 2, 4, 6, 8. So I'm going to multiply the bottom equation by 4. Because 2 times 4 is 8. And they will be opposite. One thing you should note, earlier, I didn't just multiply by 3, but a negative 3. Why did I do that? So it would be the opposite of a positive 3. Here I'm not doing a negative 4. I'm doing a positive 4 because it's already negative here. And the opposite of a negative 8 is a positive 8. So then we distribute, multiply everything, we'd have 4 times 4 is 16. 4 times 2 is 8. 4 times 3 is 12. We didn't do anything to this, did we? We kept it the same. Since we kept it the same, I'm just going to write it above it, unchanged. Now that they're opposites of each other, it's in standard form, we can just add it straight down. 7 minus 16 be negative 9x. 8 minus 8 cancels out. 12 minus 12, 0. Divide both sides by a negative 9. X equals 0. We're not done. We solve for the x. Now we need to solve for the y. We could choose either one of these to solve for the y. It doesn't really matter. I'm going to choose the bottom one. So negative 4, but instead of an x, what will I put in its place? What does the x equal? 0. Plus 2y equals 3. Negative 4 times 0 is just 0. I don't have to even write it. Look, I wrote nothing. 2y equals 3. Divide both sides by 2. Y equals 3 over 2. The answer would be 0, 3 over 2. Okay, so we covered how to do standard form. We covered how to do standard form, but with coefficients. When there is a variable solved for already. Now you can solve any of these problems with any method that we've covered in this class. But typically when a letter is already solved for, instead of getting it in standard form, which you can easily do by doing a negative 3x to both sides, a lot of times people will just use substitution. So let's do a substitution one. You need to see one anyway. So on most of the tests, you can choose whatever way you want to do it. But let's go and do a substitution. So x is already solved for. We know what x equals, so we're going to rewrite the other one. We're going to rewrite this one. So it's going to be negative 2, but what will I put instead of an x? Instead of an x here, what do we put? A negative 2. X is something, and then we'll just write the rest of it. Plus 6y equals 4. What is that something that the x is? Well, when we look up here, the other equation, we see what the x is. It's a 3y plus 7. Okay, now we just do the order of operations, right? First thing you should do is multiply, distribute. 2 times 3 is negative 6y. Negative 2 times 7. Then just bring everything else down. Collect like terms. A 6y and a 6y. So a negative 6y and a positive 6y actually just cancel out. So we end up with a negative 14 equaling 4. Now on this one, we didn't get an x or a y. We have a negative 14 equaling 4. But is that true? No, it's not. 4 equals 4. Or negative 14 could equal negative 14. When it's false, though, we don't call it false. We call it no solution, or some students like to say no so. It's also represented with a 0 and a line through it. Okay. So since it's no solution, we don't need to go and find the x or the y. We're done. Okay, and remember that if it had ended up being like something like 4 equals 4, if that had been the answer, it would have been infinite many solutions. Any value I put for x or y would work. There's no solution, there's infinite many, and then there's what we typically get, which is one solution, which is what we did earlier. Anytime you get an answer of x and y, like we did here, that's the one solution. That was the one solution. Okay, let's talk about the last one here, and that's by graphing. So So there's two different ways you can graph. One way is to make a chart and choose any values you want. Usually we choose some small numbers like 0, 1, 2. You could choose anything you want, 3, 4, 5. I'll even choose a negative number in there. And then substitute them in. If x is a 0, 0 plus what is 6? 0 plus 6 is 6. If x is a 1, 1 plus what is 6? 1 plus 5. 2 plus 4. 3 plus 3, and so on. That's it. And then you just plot the points and you're done. The other and more popular way is the slope-intercept equation. And all you have to do is when the y is by itself, when it's solved for y, you just have to find the m and the b. Y equals mx plus b. The m would be a 3. But we want to rise over run since we're graphing, so I'm going to say 3 over 1. The b would be a 2. Now, going back to this one. If you don't like to do the chart, you can always just solve for y. It's being added to, so subtract. And you could do the same thing. The m would be a negative 1 over 1, and the b would be a 6. So you can always turn it into the slope-intercept form. You can always graph it. So what would that actually look like, though? What would the answer to that be? Well, let's graph it both ways real quick. So if the b is 2, you would rise 2. And if you rise over run, you go up 3 over 1, up 3 over 1, up 3 over 1. And what I like is you can also do it in reverse. You can make this negative as long as this is negative 2. And you could do that because a negative over a negative is a positive. Essentially do a negative 3 over a negative 1. So go down 3 over 1. So that it does help when you have more dots to draw a straight line. Ensuring your math will be more accurate. As you can see, I got a paper this time to help me out. Okay, and then how would you do this one? It's just plotting. If x is 0, y is 6. 1, 2, 3, 4, 5, 6. Notice I didn't move at all left or right on the x-axis because it was 0. If x is 1, start the origin, go over 1. The y would be 5, right? So go up 5. 1, 2, 3, 4, 5. Actually, you can see where they're going to hit already. But you can just plot them all. If x is 2, 1, 2, y would be 4, 1, 2, 3, 4. If x is 3, 1, 2, 3, y is 3. And then just at the dots. And where they intersect is the answer. That's the one solution. So they intersect at 1 over 1, and they go up 1, 2, 3, 4, 5. 1 and 5 would be the answer to those two graphs, and where they meet, it'd be the answer to this system of equation, x plus y equals 6, and y equals 3x plus 2. Two different ways to graph, but on the test you could do either way. Although there's not a lot of graphing, I think there's 1 or 2 questions where you have to graph. And there's also a question where it's going to ask you to look at the answer and say where is it located. So, you know, count the x's and then the y's. X always goes first, and then the y should be able to get it. Okay. Sometimes you have to graph, but the y is not already solved for. So you have to solve for y. I think that there's one question on the test like where it's asking you to graph and you have to solve for y. So it's easy. What's being done to the y, and do the opposite. In this case, the y is being added by a 3x. So just do a negative 3x to both sides. You have y equals negative 3x plus 10. Then find the m and the b. Right? Y equals mx plus b. Some common mistake people often make is when they subtract these, they forget that you can't actually subtract them because this has an x and this doesn't. So you just bring them both down, and you bring down the one with the letter first. Same thing on this side. What's being done to the y? Two things. It's being multiplied by a 3. It's being added by a 2x. What do we undo first? Order of operations. You undo what's being added first, then what's being multiplied. So we subtract 2x from both sides. Remember, you can't add these together, so they're not like terms. You're just going to go down. And then we divide. Since it's being multiplied, you do the opposite. All right, so now we can easily find the m, and we can easily find the b. And we don't even care that it's a fraction, because we're just going to do a rise over run, so it doesn't even matter. Okay, so let's go here. I'm not going to rewrite the whole equation. I'm just going to write the m's and the b's on this page so that we can easily follow. So the m equals a negative 2 over 3, and the b equals 3. I should probably use a different color marker for the other equation just so it's easier to follow. The m is a negative 3 over 1. And the b equals 10. Okay, so I don't know, let's do the pink one first. The b is 3. Start at the origin, 1, 2, 3. And since it's negative, instead of rising and going up, it's negative, so we're going to go down. We're going to go down 2 and over 3. Only make the one thing negative. Don't, 3 is not negative also. It's just the 2, and the 3 we're keeping positive. So we're going down 2 from where we left off. A common mistake is people sometimes forget that you need to count from where you left off. Okay, and you could do it in reverse. You could go up 2 and over 3 that way if you wanted. That's enough to have a pretty straight line. Let's see what that would look like. It's a straight line. How do you like them apples? That's just same snack time. So almost done. The last one is b equals 10, right? So we're going to go up 10. Remember, the b is where on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we're going to go down 3 and over 1. So down 3, over 1, down 3, over 1, down 3, over 1. You can see where they're going to connect, right? Do it one more time. Okay, just draw a line. There we go. It has one solution because they're touching. What's the answer? The answer is 1, 2, 3. So it went over 3, up 1. So the answer to this equation is 3 and 1. And you could even check it if you wanted. You could check 3. I'll rewrite this one here. The answer was 3 and 1, right? So 3, instead of an x, I'm going to put a 3. Instead of a y, I'll put a 1. Uh-oh, someone's knocking on my door. 9 plus 1 equals 10. You could also check it on this side. 3, rewrite this, plus, sorry guys, I'm not supporting the candidates. I have a virus or something on my computer. Keeps funny messages. 1 second, I'm recording the video, hold on. 6 plus 3 equals 9. So it checks out both ways. Anyway, this concludes the video. I hope it was good for you guys, as it was for me. Good luck on your test.